The essentials of civil estimation. Introduction to the module. Civil estimation lies at the core of every construction project, transforming ambitious designs into well-planned realities. It plays a crucial role in ensuring resources are allocated wisely, budgets are accurate, and timelines are met. By mastering the essentials of estimation, civil engineers gain the ability to manage costs effectively and contribute to the success of any project. From this module, you will explore the purpose and importance of estimation, understand the various types of estimation, and learn the foundational principles and terminologies that drive this process. You'll also dive into methods for estimating material quantities, perform quantity takeoff techniques, and examine how advanced tools like 3D modeling and BIM are reshaping the industry. Learning objectives. By the end of this module, you will be able to understand the purpose and significance of civil estimation in construction projects, learn key terminologies and principles essential to estimation, apply methods for accurate material quantity estimation, perform basic quantity takeoff techniques effectively, explore the role of 3D modeling and BIM in enhancing estimation accuracy and efficiency. Overview of cost estimation in civil engineering. Cost estimation in civil engineering is the process of forecasting the financial expenditure required for a construction project. It plays a pivotal role in determining the viability of a project, ensuring that resources such as materials, labour, equipment, and time are effectively allocated and managed throughout the project lifecycle. Cost estimation is especially critical due to strict regulatory standards, the economic environment, and the complexity of modern construction projects. The purpose of cost estimation is to calculate the total expenses a construction project will incur, considering all required resources. Estimation encompasses a wide range of factors such as materials, labour, equipment, and time. Each of these components must be accurately predicted to ensure a project stays within budget and adheres to scheduled timelines. Materials. Accurate estimation of materials is vital as it directly affects the cost of raw materials, transportation, and storage. The fluctuating prices of construction materials like steel, concrete, and timber in the market can significantly impact the overall cost. Labour. Estimating labour costs involves considering the workforce size, required skills, and wage rates, which can be influenced by factors like union agreements and regional wage differences. Labour productivity is also factored in, as it determines the efficiency with which tasks are completed. Equipment. Estimating the cost of equipment includes both purchase and rental costs and maintenance expenses. The use of specialised machinery, such as cranes or excavators, adds another layer of complexity to the cost estimation process. Time. Time is a critical resource, and estimating the duration for each phase of construction is essential for cost control. Delays are often subject to penalties, making accurate time estimation a vital aspect of project planning. Types of cost estimation methods. In civil engineering, various cost estimation methods are employed at different stages of a project, each offering varying levels of detail. Preliminary estimation is a rough estimate made early in the project to assess feasibility and scope when limited information is available. As the project advances, detailed estimation is used, involving a comprehensive breakdown of materials, labour, equipment, and overheads, based on finalised specifications. Quantity estimation focuses on calculating the quantities of materials needed, forming the basis for procurement and negotiations with suppliers. Bid estimation is used by contractors to submit competitive bids, incorporating all project costs, including materials, labour, and profit margins, to propose a final contract price. Time-based estimation is useful for projects where labour shifts and equipment rental schedules are crucial, estimating costs based on the time required for specific tasks. Activity-based estimation breaks down costs according to individual tasks, allowing for more detailed tracking and management. Lastly, lump sum estimation involves a fixed price for the entire project or specific portions, typically used when the scope is well defined and unlikely to change significantly. These estimation types ensure cost accuracy and control at various project phases, helping to manage budgets effectively. Terminologies and principles in estimation. Understanding the terminology and principles associated with estimation is essential for civil engineers to make informed decisions. Below are key terms that are frequently used in civil estimation. Bill of Quantities, BOQ, a detailed document listing all materials, labour and services needed for the construction project. It serves as a reference for the estimator to determine quantities and costs. Contingency, a reserve of funds, included in the estimate to account for unforeseen costs or changes in project scope. The typical contingency allowance can range from 5% to 15% of the total project cost. Overhead costs. These include indirect costs such as administrative expenses, insurance, and other general expenses not tied directly to a specific task. Unit rate, the cost per unit of a material or service, often derived from previous project data or supplier quotes. Markup, an additional percentage added to the cost estimate to cover the contractor's profit margin. Risk analysis, a process for identifying and evaluating risks that may impact the cost or timeline of a project. Risk management strategies are employed to mitigate these factors. Applications of estimation in construction projects. Cost estimation is essential throughout all stages of a construction project, ensuring its successful execution. During feasibility studies, preliminary estimates help determine the financial viability of a project, offering clients an early understanding of cost and guiding their decision on whether to move forward. In the tendering and bidding phase, contractors use detailed cost estimates to submit competitive bids, accounting for all costs, including contingencies and risks, ensuring profitability while staying competitive in the highly competitive tendering environment. Procurement benefits from accurate estimates, enabling project managers to acquire the right materials and resources at the best price and avoid unnecessary cost overruns. Throughout the construction phase, cost control and monitoring relies on regular updates to estimates, ensuring that projects stay within budget even when unexpected challenges arise. Finally, during project closure, final cost estimates are compared to actual expenditures to evaluate financial performance and pinpoint areas for improvement in future projects. In essence, cost estimation serves as a cornerstone in managing and executing construction projects efficiently, providing insight and control from start to finish. Introduction to quantity. Takeoff techniques. Quantity takeoff, QTO, is a fundamental process in civil estimation involving the measurement and listing of materials required for a construction project. It is essential for determining the quantities of materials needed for accurate cost estimation, procurement, and budgeting. The process involves analysing the project drawings, architectural, structural, and MEP to extract the quantities of materials such as concrete, steel, timber, or earthwork. There are several techniques used in quantity takeoff. Manual takeoff. Traditional method where estimators manually measure quantities from drawings using scale rulers or digitizers. This method is time-consuming and prone to errors, but is still used for smaller or simpler projects. Digital takeoff. Software tools like PlanSwift and Bluebeam Review have made this process more efficient. These tools allow estimators to extract quantities directly from digital drawings, reducing the time and chance for error. Automated takeoff. This method uses sophisticated software to analyze drawings and automatically generate quantities. Programs like Trimble and Revit, when integrated with BIM, offer more accuracy and efficiency, especially in complex projects. Methods of estimating material quantities. Estimating material quantities involves selecting the appropriate method based on project requirements and the available level of detail. The primary methods used include unit rate method. This method calculates the quantity of each material based on the standard unit rate for a specific task, for example, cubic meters of concrete for foundations. It is most suitable for projects with well-defined tasks. Component method. Here, the total quantity is calculated by summing the quantities of individual components, such as beams, slabs, or columns, and multiplying them by the unit costs for materials. Approximate quantities. Method. Often used during preliminary stages, this method estimates material quantities based on past experience or rough approximations when detailed designs are unavailable. Bill of Quantities, BOQ. A BOQ lists all materials and quantities needed for a project, enabling accurate procurement. This document serves as a basis for cost estimation and tendering. Use of 3D modelling and BIM for estimation. The advent of 3D modelling and building information modelling. BIM has revolutionised the process of estimating material quantities in civil engineering. In the UK, where construction projects are often complex and data-intensive, BIM plays a critical role in providing detailed, accurate, and real-time estimations. 3D modelling involves creating a digital representation of the physical and functional characteristics of a project. This model not only provides visualization, but also helps in estimating material quantities more accurately by directly measuring the virtual components of the model. Tools like AutoCAD and Revit allow estimators to interact with 3D models, extracting precise measurements for every material required. BIM, Building Information Modelling, goes beyond 3D modelling by integrating various aspects of a construction project, including costs, scheduling, and even lifecycle management. BIM allows for the creation of a digital twin of the project, providing real-time updates on material quantities and helping estimators make accurate and informed decisions. It also facilitates collaboration between architects, engineers, and contractors, ensuring consistency across all project aspects. The use of BIM not only enhances the accuracy of material estimates, but also helps mitigate potential errors and omissions, reducing costs and improving project efficiency. With BIM, civil estimators can also predict the costs of labour, equipment, and time required for each phase of construction, making it a crucial tool for modern civil estimation practices. Highlights from this module. Cost estimation forecasts financial expenditure for construction, ensuring effective resource allocation and project viability. Accurate material estimation impacts raw material costs, transportation, and storage, considering fluctuating market prices. Types of cost estimation methods include preliminary, detailed, quantity, bid, and time-based estimations for project phases. Quantity. Takeoff involves measuring materials from project drawings manually or digitally, using tools like PlanSwift or Revit. BIM integrates cost, schedules, and material estimates, enhancing project accuracy, collaboration, and efficiency. Thank you. You have successfully made it to the end of this module.